Okay. Okay, perfect. Hello everyone. Welcome to the fourth iteration of this problem solving session. My name is Raj and I'm a PhD student at IISc. So today we'll do the week 3 programming assignment in detail, and then week 4 lectures, that is a merge sort, quick sort, and some ideas and some things on tuple stirred function, etc. And then if time remains, we'll get into exception handling and stuff like that, which is a week 5 syllabus, right? um, this time they're given the solutions also by the instructor for the different programs. So we'll just go through the different ideas here, and then we'll see how it helps. Okay. Let's start. So the first question is about writing a function that's called as expanding, which takes in as input a list of integer L and returns true if the absolute difference between adjacent pairs of elements strictly increases, right? So one thing what we are given is it's a list of integers only. Uh, and what we want to check is that, let's say here, if I have 13729, then 1 minus 3 minus 1, or 1 minus 3, basically the difference is 2. And next difference is 7 minus 3 is 4. 2 minus 7 is minus 5, but the absolute difference is 5. So then you can see that the difference is actually increasing, and it should strictly increase. That is, even if the difference remains the same between two adjacent elements, then we won't say it's an expanding list. Okay. So that's the idea. Now they are given two versions here. One is the iterative version. Sorry, this iterative version, and one is the recursive version. Okay, so we'll go through each of them and see how it works. Right. Um, yeah, let's take this for example. Um, yeah. So first of all, we'll see what is the code here? The code here, it says first line is basically if the length of L is less than 2, right? So if there are only 2 or less than 2 elements in the list, then obviously it is expanding, right? There's nothing else to compare. So we just say that it is expanding by default, right? If it is that means, if it comes out of this condition, that is, if it comes to this particular line, that means there are at least 3 elements, right? So therefore, we can check whether the first difference is strictly smaller than the second pair of elements difference, right? What we're doing here, basically, L of 1 minus L of 0 gives the difference between the first two elements. Its absolute gives us the absolute difference, and then we're checking that difference with the next two elements, 1 and 2. L of 1 and L of 2 will give me the second and third element difference. So if it is strictly less than the this one, then it's fine. And what we are saying is that for any list, you can just check whether the current difference is having that this rule, whether it's expanding or not. And if the rest of the list is also expanding, then I would return the AND operation of them, right? That is basically this particular element. First three elements have this rule satisfied. So just check for the remaining list in the same way, right? So therefore, what we're saying is, we're saying if the first three elements have this expanding rule, and the next the remaining of the list also has this expanding rule, then the current list that is being given as input all has the is expanding in nature. Okay, so that's the idea behind the recursive call here. Okay, so we'll go through a simple example. Mm, um, yeah. So first, in the first call, we have L as 12 elements here, right? Obviously, this condition won't be true. And then what we do is we get into the first difference, right? So here, difference, as you can see, is 3. right? And just to make our lives a bit easier, I'll just write next step is equal to, okay. So, right. So what we have here is diff is 3 and next diff is 5. So therefore it is expanding. At least for the first three elements, it is expanding in nature. So then we say, okay, for the first three elements, it is there. Check for the next pending list, right? So then we'll go. So then the call, it's a recursive call. So we'll have again the same function being called, but now we're saying check for the remaining list, right? So L of 1 colon will tell you from the second element you have to take. So here, minus 1, 2, 3, minus 3, 4 was there. So in the recursive call, it will start from 2, right? Which is exactly what's happening here, right? So now we have a list of 11 elements, which was the from the second element of the initial list. Okay. So again, we'll do the same thing, and we see 5 and 7. 5 is less than 7. So again, call the next, expanding list. So again, we see 7 and 9, right? So we see that it's still expanding, and then 9, 11, and then we see 11, 13. Yes, it's expanding. And then 13, 15. Yes, 15, 17, 17, 19, 19 and 21, 21 and 21. So we got two differences which are exactly the same, right? So then we will say that it is not expanding list, right? So now what we'll do is we'll return false from this particular call. And now in all the previous calls, it was having true and then whatever the result is there from the recursive call. Because now the recursive call is going to give you false, and we have an AND operation. Each of the recursive calls will now have the return value as false, right? So hence it will end up printing false. So let me just print the result here. Okay, so we see false here. Is that clear? Does that help? Now let's say if I had changed this order of operations like this, if I had done expanding of L1 colon and this one, do you think this is going to be a huge difference? Any thoughts why, will this cause any problem in the output? Sorry.
What is the change you have made now?
So previously, this was the, so this is what is given, right?
Uh-huh.
So previously it was diff and diff less than next diff, and then we call this one versus let's say this one, right?
Mhm.
So in terms of the output, will there be any difference according to you guys? Any thoughts?
So sequence has changed. Okay.
Sequence will have changed, but does it matter in terms of the output of the function? I'm sorry, I can't hear you. Who's speaking? Uh, Karan, I can't hear you at all. You can just type it in the chat box. So here, so here, um, program will now run the expanded function from second value and later check for increasing. Yes, but how does that matter in terms of the output of the function? Does the output change? Will you get wrong answers if you were to do this sort of a thing? Any thoughts? So again, remember that the AND operation is basically a uh, which doesn't affect by the order of the um, arguments here, right? So true and false is false, and false and true is also false, right? Um, so therefore, in terms of the output, it won't affect, correct? But what do you think in terms of the running time? Let's say if I had to if I were to run this program um, versus run this version, what do you think will there be a difference then in terms of the running time? So let's just see that. Um, so I've changed the list in a slight of a bit slight change. Okay, so we'll just make it a bit simpler. Um, okay, so here very clearly it is not an expanding list, right? Because this difference is, let's say, 3, then this difference becomes 5, this difference becomes 4, right? So obviously it's not going to be. Um, Running time will be slower for the second case as recursion causes delay in execution. We are doing recursion there also, right? In what specific cases will it cause slowness? That's the question. That would be the thing that you would have to think about, right?
Yeah.
So
If diff that itself falls, first one, then
uh,
it may not evaluate in the previous case the next one.
that is
So
exactly correct. Yes,
yes,
that
so
is exactly correct.
yeah, that precedes this one, right? And so that much time it goes.
Yes, that is correct. Exactly correct, right? So
Yeah.
Python does this very neat sort of optimization, at least in the case of AND, right? So where the idea is that because the way your AND truth table is, if any one of the arguments is false, the output is going to be false, right? So there is no need to evaluate the second part of the expression if the first part is already false, right? So that's exactly what we will see in case of this particular example, right? Let's say we'll call this V1 and we'll call this V2, right? One, or no, so just keep this V1. So V1, right? And V2, right? Okay, so here what we're doing, a very simple, again, everything is exactly the same. It's just the fact that we are changing the order of operations here. Now, because of the Python's neat trick, we'll see why it's working. Let's do V2 first, and then we'll do V1. Yeah. So uh, so in V2 now as you can see for the first call, I have the whole list here. We go to the diff and next diff, right? And 3 is less than 5, right? But we're not using that information yet. We're asking the Python to first evaluate this and then evaluate this, right? So it will immediately call the resulting sublist operation. So it'll go here, 2, -3, 1, and 6, and all of that. 5 is less than 4, right? But it is not going to use that information still because we have asked the Python to first compute the call of recursion, right? So then it'll go back here. It'll do all the way until until this. length of list is less than or equal to 2, which is in the, it'll come here now. That's length is 2 now, right? It'll return true, but now there was one of the conditions where diff was less than diff was greater than next diff. Therefore, it'll be the final call is going to be false. But you went through the whole list completely, right? Now let's look at V1. That is the first version, right? So um, here what will happen is, yeah. So first call, 3 is less than 5, that's correct. And then second call, I would have 5 is not less than 4, right? And then so immediately it will exit and it will print false. Okay, so this optimization actually helps Python to evaluate less and as well as get the answer quickly as possible. Okay. Um, fine. This is about the recursive version of the expanding, which was given in the solutions. Now let's look at the iterative version. Iterative version again, very straightforward. Um, The idea is very simple. So what we're doing is, again, the first condition is true anyway. If the length is less than or equal to true, 2, we just assume it is true, right? The list is expanding. And what we are computing here is we basically need to compare two things. We need to compare some difference of the next two with the with let's say current two elements, right? So that is what we're trying to start with here. So old diff represents the previous difference or the current difference, and new diff talks about the new difference that has come about, right? So here what we do is we start from the third element, right? Because we know for a fact that the list is greater than has at least 3 elements. So we then start with them from the third element until the end of the list, and we for every item we compare we compute the difference of that element with the previous element. That's the new diff. And now we compare the differences. So new diff is less than old diff. If it is so, then we return false, right? Because differences have to be increasing strictly, right? If it is not so, we just we move on to the next item. And when you move on, basically your new diff becomes the old diff because now you have moved to the next element, right? And the idea is that if you have gone through the whole of the list without exiting here, that means every time new diff was greater than old diff. So therefore I can return true. Okay, that's the idea. We'll just see it in we'll just see it in action. So let's say, yeah. So currently we have a big list here, and then old diff is 3. That is a 2 minus of -1, and then we start from the third element, right? So new diff captures the -3 of -2, that is 5, right? Absolute value. And then, so now we see that new diff is greater than the old diff, right? So therefore, this condition will not be executed. It'll come back, it'll move to here and it'll say, now you make the old diff as a new diff, right? So now old diff became 5, and now we have moved on to the next element. So now we need the new difference again, which is exactly what we're computing here, right? And then we compare 5 and 7, and again, it's fine. So we just move on. We give 7 to old diff, and again, compute the new diff, 9, and so on. Okay. So, uh, yeah, we'll come here, I think. So almost all the whole list we have gone through. And this is exactly where we stop, right? Because now we're saying that new diff and old diff are the same. So hence the list is not increasing strictly, and therefore stop. And we'll return false here. Okay. Any doubts in this? No? Okay. So we'll now move on to the next thing, which is quite straightforward, which is basically what we want to do is we have been given a write a function called a sum square where it takes a non-empty list of integers. So we are given compulsory that we'll have at least one entry in the list and returns a list which is of the two elements, odd and even. So where odd is the sum of squares of all the odd numbers in L, and even is the sum of squares of all the even numbers in L. All right. So very straightforward. We'll say odd sum is 0 and even sum is 0. We'll start from there. And for every element in the list, because L is here, so for every element in the list, we check if the number is even or not. Right. So even or not, basically, how will you check? You'll check if the remainder by 2 is 0. So if it is 0, then the number is divisible by 2, therefore it's even, otherwise odd. Right. So that's what you're trying to do here. So if it is even, then you add that particular number's square, that is n into n, to the even sum, right? Again, remember, this is basically going to be expanded as even sum plus equal to becomes even sum plus n into n, right? So therefore, when you give the first value as 0, this helps you not, keeps your sum proper, right? So you will have 0 for the first ever element, you get even, you get 0 plus n square, which is exactly n square, right? And then similarly here, right? So what we're doing here is just the adding something based on a condition. That's it, right? And what we want is we want output to be a list of two elements. So we construct the list here. We construct the list as two elements, which is your odd sum and even sum. Okay. So let's just see it in action, right? Um, Yeah, so what we see first, even sum, odd sum is 0 for n in L. So n is the first element, that is minus 1. Minus 1 is not even, so it's going to come here, right? And then minus 1 square is 1. It'll get the odd sum will become 1. Right? That's exactly what's happening here. Similarly, then we continue. Next element is minus 2. Minus 2 is even, so it's going to come minus 2 square is 4. So even sum becomes 4, right? Then we have 3. 3 is odd, so it's going to come here. 3 square is 9. 9 plus 1, that is becomes 10. So odd sum becomes 10 here. Okay. Similarly, last element is 7, which is also odd. 7 square is 49 plus 10 is 59. So that's going to become 59 here, right? So finally, what we get is even sum is 4, odd sum is 59, right? This is exactly what we get here. Okay. Simple, straightforward for loop. And inside the for loop, you have a simple check, right? Simple if condition uh, uh, based on even odd. Okay, right. Then let's go through the last question. Last question is basically transposing a matrix where you represent a two-dimensional matrix as a list of lists, right? So where, for example, let's say if you have a matrix which is which is of this form, you will represent the first row as one list, then second row is another list, and these two will be the lists again inside a bigger list, right? Um, and that's how you want to represent. You have the matrix and you want to transpose a matrix, right? That's basically, then you will have, so in this case, you have two rows and four columns. When you transpose a matrix, you will have four rows and two columns, right? So that will drive your first logic. There is how many rows should be even present, and then you will fill the rows one by one based upon how you iterate. Okay, so let's just see that in action here. Okay, so yeah, so first we have this matrix as 1, 2, 3, 4, 5, 6, 7, 8, 9, and then look again very carefully. Uh, L of colon 1. Okay, so that's basically only the first sublist. right? So L of colon 1 gives you the first row again, but as a matrix, right? So it's one row, three columns sort of a matrix, right? And then we are saying for row in this. So then in this colon 1, it's a list having only one element in it, which is again a list. So this row becomes 1, 2, and 3 as a list, right? So you can see row is the first row, which is proper, right? Now what we're doing is we're saying, okay, how many ever elements are there in this row? You make so many empty lists in the final matrix, right? That's basically what we're saying is we're saying how many columns are there, right? Because in this row, if I have three elements, that means there are three columns in this matrix. So in the final output that I want, it should have three rows in that also, right? That's the idea. Okay. Uh, or let's just do this matrix actually, because it'll, yeah, just a moment. Ah, yeah. So here again, row is the first row. And what we're doing is we're saying for I in range of this one, just append an empty list here. We're saying make four rows in the output list, right? So that you can see here. So here out L has one empty list, second empty list, third, and then the fourth empty list. Okay, so that completes this loop, right? This loop is over. This loop is also over because you were saying we want only one element, right? So all of this comes out to finally here. Okay. So now what we'll do, so now that we have the four rows with us in the output in the transpose matrix, we just have to fill the elements in that particular rows, right? So for that, what we'll do is we'll say, okay, for every row in the initial list that was given to us, okay, and then for every one by one, you just go through that particular row, and here out L of I basically tells, so what is I here? Again, I remember here I is the column number in the original list. So that becomes the row number in the output, correct? So we are saying out L of I is the row. You append that particular column value. Row of I is the particular column value, right? So that becomes in this format. So again, just keep an just watch out for this out L variable. Okay, so one, and then one, two, three, four were in the first row. Here, one has become gone to the first row, two has gone to the second row, right? Which is exactly what we want, right? So three and then four, and this completes the first row. We'll now move to the second row. So now row has changed, and exactly what we're doing here, right? So five, six, we're just going to append the elements all the way. Okay. So out L is basically exactly what we want, the transposed version of it. Okay. Um, does that help? Any thoughts, any questions? No? Okay. Um, so why can't I do something just like this, right? I mean, so see, what is this part of the code doing? It's just creating, empty lists, four empty lists based because we have four columns. So why can't I just do like this? Let's say I get the number of columns as I'll say L of 0, length of L of 0, right? So the L of 0 gives me the first row. Number of elements in that list is the number of columns, right? And then I can just do out L as um, em empty of this, right? So empty into number of columns. Can I do this? Is there any issue in doing this sort of a function? What particular scenario will this so there's an assumption that we are taking in this particular sort of a code. um, can anyone think of what assumption is that, and can it be, can would it be broken if something else is given as input here? So so here when we are saying L of 0, we're saying that we are sure that there'll be at least one row, right? There's at least one row present in this list, right? But what about empty matrices, right? So for empty matrix, you will represent it as something like this, right? Basically, it's a null matrix. There's no elements in this, list. Then this sort of a code will help you save from that, because then you will say, okay, for row in L of first column, which is there are no elements, so therefore this iteration itself will not go through, right? And what will end up happening is you will just end up giving out the same empty list, right? Whereas in this case, that will cause an index error because there are no elements in the list itself. Okay, but otherwise, then these two are if you're sure that there are elements in the list, then these two are similar, same, right? It'll do exactly what this particular part of the code is doing. Okay, um, fine. So this uh, closes the programming assignment part. Um, okay, let's just see some questions here. Uh, so week 5, we'll focus on week 4 today. We can do week 5 next week. Is that okay, Anandita? You can try until then. Yeah. So Ashwani, this record, all of the sessions are recorded and the links are provided here. Okay, problem solving session, and then problem solving session recording. You can just go here, and this has a link to the um, uh, all the recording that we TAs do. Okay. Okay. So shall we go through merge sort then? If everyone any doubts in the merge sort code? So for example, let's say this is the exact implementation that we have from the course, right? Um, so let's see if we can figure out how this code is working. So in this case, so your merge sort, basically the idea is very simple, that the recursive case is very straightforward. What we do is we say, okay, you merge sort, you sort the first half of the list, then sort the second of the list, and whatever resultant you get, you need to merge them with some with some clarity, right? So that merging is where the whole magic happens. So and here the idea is that in the merge function, because we are sure that what input we have given are individually sorted, that's exactly why we are able to do this merge in a more efficient way, right? And again, the idea is very simple. You will go through both the lists, A and the B list, for example, in this scenario, and you'll keep comparing the initial elements in the A and the B list, right? And in case the A list has smaller element, you will then use that in the new list, let's say C, right? uh, Vice versa, if B has a smaller element, you will use that particular element in C. And once you exhaust either of A or B, then you will just keep continuing until the both the lists are completed. Okay, so let's just see how it goes. So here in merge sort, the idea is that you say you want to slice the list from left to right, right? Because it's a recursive call. We provide this additional arguments. In this case, we will say that, I want to sort the whole list. So therefore, sort from the first index, that is 0, until the length of unsorted. Okay, that's exactly what we want here. And let's say we will just say sorted list, and we'll see if it is sorted or not. Okay. Um, so let's just set up these things here. Yeah. So again, remember how we how we did the in this particular example that we did, right? We said first you need to the order of stuff here. So here also what we're saying is first you need to do the recursive call, right? You finish a recursive call first, and then you do the merge condition, right? Here we could reverse this, change the order of the operators, because AND operation by default doesn't have any order as such. But whereas here the algorithm uh, depends on the fact that the merge function depends on the fact that the two lists given to it are ordered by themselves. Okay, so we'll go one by one. So let's say the first merge sort recursive call is here, and we're saying you sort from the 0 to 4th position, which makes sense. You have 8 elements. 0 to 4 is given to the first, the left half, and remaining will be given to the right half, right? So we'll go back. We'll go here now. Now we are saying you sort this list, but from 0 to 4. That's the length you need to sort. And again, we'll again divide into two parts, and then come back here, and then we'll say 0 to 2. So two elements are present in this list, which is the first two. And then we'll say, okay, go until the base case. And here is where we stop. We say, so we are saying that the right minus left is less than or equal to 1. That basically means that there's only one element in that particular sublist, which is your A left to right, right? Obviously, any list which has only one element is already sorted by itself. And that's the idea of this base case, right? So that basically returns this list as the output, which is your, in this case, it will be 43, right? Okay. Uh, Now, remember, we had come here from this particular function, right? So this L in this function would become that 43 list, right? That's the output from this particular recursive call. And now we are in the previous function. Uh, our we are saying you merge sort this particular element. Okay, so that's going to come here, and we'll do one thing. Yeah. So this will again say, okay, you go sort from 1 to 2, which is again going to be basically the base case, which is just one element sorted by itself. Okay, and then we say, okay, you merge now left and right. Now here see, left is 43 single list, right is 32 single list, and we'll see how the merge function runs here. Okay, so very straightforward. Um, uh, yeah, so I and J are basically telling you which position we are going to compare between the two lists A and B. And what we see here, first of all, yeah, so we'll come exactly. So obviously these two cases are not true, and we come to this case where A of I is less than or equal to B of J, which is not true, right? So we come here and we say, yes, A of I is greater than B of J. So then you append to C the element B of J, that is 32, right? So that's exactly what becomes to C, right? And then you increment J. That's the idea. You increment J and you say, okay, I have gone through I've gone through this particular element in the B list. You can now compare with the next element. Here, there's no next element left. Uh, which is exactly this condition, right? J is equal to N. So we'll now just append the elements of A in it. Okay. So now, as you can see, C has become the uh, um final output that we get is a sorted list between these two sorted lists themselves, right? So A and B were sorted by themselves. We merge them such that this the sorting remains intact, right? Uh, and that becomes the output for the previous call in merge sort. Okay, so that was exactly what was got what was sorted in the first so the left half of the left half, right? That's exactly this L. Same thing will happen for the right. um so we'll come back here. Yeah, this is 22 and 78 again. um So 22 and 78, again, these are sorted by themselves, but this condition becomes true. That is 22 is less than 78, and you will then move that 22 into C, right? As you can see here, right? And then uh, so A has become empty now because they've gone through all the elements in A. Will now append the elements in B, right? And we complete here, we get 22 and 78 here, right? This is where the condition comes into. So where now we have two lists which have two elements in by themselves, which are sorted. Now we'll see how to combine these correctly. So we'll see first between 32 and 22. This should go into the C list first, right? That will happen from this condition where A of I is greater than B of J, right? So here we will now append 22 into the list C, right? And increment the only J, that is the B list's head, right? And then, so now we are, so again, see, remember, this element is done in B. We now compare 78 with the rest of, with the 32, right? And that would come up here, right? Where A of I is less than 78. So that would increment A's pointer. Then you get into, so now we'll compare 43 and 78. Again, A is going to increment itself, right? And that's, you got 43. And again, remember, now we have completed all the elements in A. So we'll now move into this condition where, sorry, yeah, this condition where A is empty, right? So you'll now just append elements of B, which is 78. Okay. So that's how we got the final list. So we have two lists which were sorted by themselves, and then we have formed a merge list which is now sorted by itself. Okay. Um, Again, so we'll skip a few things. Um, we just see how the elements are going into the C list finally. So again, see here, 5763 is the output of C. 91 and 13 again sorted. Now this is the previous two that we got. Those their merging gives you 13, 57, 63, 91, which is exactly what we have. Then finally, we had two halves, that is left half and the right half of the original list. All of those are now sorted perfectly here. Okay, that's how we get the sorted list. Okay. Um, any doubts here? Any questions? Any doubts here? Hmm. Okay. Did you guys understand at least what I spoke? Okay. Mm, then let's say we look at quicksort. So quicksort, again the idea is quite novel. Uh, How to achieve the list in descending order. Right. So what do you think you would have to change in the merge sort program to get the descending order list? Where is the exact ordering getting affected? Any thoughts? Again, the question is open to everyone. Swap left with R and right. So you want to swap left right with right left? No, that doesn't matter, right? Because you can give. So by the way, if I just write RL here instead of LR, that doesn't matter because the idea is what is merge doing? Merge is looking at it's saying it just needs for a fact that the two lists that you have given should be sorted by itself. It will then arrange the elements accordingly, right?
Yeah, return left, right, you have written. There, instead of that, right, left, you can return.
No, you're saying if I do this,
There, so right side is higher one, left side is lower one, right?
no, but who said right side is a higher one and left side is lower one? Because these are just sorted by themselves, right? At the end of the day.
Okay.
So let's just see. For example, if I run this code with this one, I still get the same output. Swap greater than with less than. Who is this lady? Who is her? Some C. Okay. Yeah. So swap, that's correct, right? So in the merge function is where all of this check is happening, right? So we are saying that if A of I is less than B of J, then you append A of I. So here rather now the condition would change to if A of I is greater than B of J. Right? Or then you take A of I because then you're saying among the two, whatever I'm comparing, which is the higher one, take that first. So then what will happen? You will keep on getting elements in the decreasing order because you'll say you'll get the highest element first and then the a small element and then so on and so forth, right? So let's just see it in action. For example, if I were to change this to greater than, right? And this to less than or equal to, right? So if I do that, you can see very clearly that we get a descending order list. So 91 first, then 78, then 63, and so on. So again, remember in merge sort, the major portion of the work is happening in the merge function, right? I mean, this is all straightforward in the sense that this is basically giving you that logic that okay, um, if you sort the left half, right half, then they are sorted by themselves, right? The merge function is doing the heavy lifting. And importantly, the base case. In the base case, we are saying that if you have a list with single element that is sorted by itself. Now that's where also another point comes in. If it's only one element, you can call it is ascending list or descending list. It doesn't matter, right? Hence, the base case also remains unchanged. If you had tried to do the base case with two elements, let's say, right, you will say, okay, I have two elements. I will sort at that level itself. There you have to be very careful if you want a descending order list. Okay. But here, because it's only one element list, then the base case also remains unchanged if you want to do, let's say, descending order. Okay. Uh, does that, does that, is that clear? Okay. So yeah, so again, so in quicksort, the idea is that you will pick, let's say, any one element. In this case, we pick the first element, sort of, right? And we say that okay, you take that element and that becomes your pivot. So you find the right place for that element, for the pivot element. And then once you got the right place for the pivot element, you then sort the whatever the elements are present left of it and right of it, right? That's the idea of quicksort. So we'll see it in action here. So again, quicksort takes again three arguments. One is your list, obviously. Then we're saying sort the list from left to right. Here we want this whole list sorted. So we'll take 0 to length of unsorted. Okay. Um, and right. So then we'll say, let's do debug here. Yeah. So, so here what we have done first here, again, remember, we take the first element as the pivot element. So in this case, 43 is the pivot element. And this yellow basically tells you what is the, I think the less than portion, I think, right? In what is the convention he has used? Um, Yellow is, I think, the less part. Yeah, right. Okay, so all the elements which are yellow should basically they basically represent the elements which are lower than the pivot value, and green are basically the ones which are greater than than the pivot value, right? So now here we'll say yellow is left plus one, that is the second element from there is what we want to check, right? And then green goes from the third element, that is left plus one, right? Sorry, from the second element, right? So until the this one, and then we check if a of green is less than a of left. Okay, that is we're checking whether this particular whatever the green element we think that it is bigger. If it is bigger, then what do we do is what we are checking. Okay, so if it is less, then we have to swap the green and yellow, right? So in this case, we'll just keep seeing how what happens. First of all, green is 1, left is 0, right? So 32 is less than uh, 40. No, yeah, yeah, less than 43, less than 43, right? So this condition is going to become true, right? So then what we'll do is we will say, okay, you have to increment the yellow pointer, right? Um, and you will do that by doing this swap operation, and then basically get into the basically increment the yellow pointer here, right? So yellow is 2 now. Okay, then you keep on going. If a of green is again green is now 2, so which is basically 22, right? So that's again going to be not a problem, right? And you keep incrementing it. Then you get green as, let's say, 3 here. Now that's the idea here, that is 78, right? So 78 is in the right position. So we don't have to change the yellow pointer anymore, right? So green is exactly correct. Then you again do for 63, which is fine. 57. Again, remember, green is 5, so it's 57 is what we're comparing, which is fine. 91 is also fine. Then is now is where the game starts. So green is 7. A of green, right, is 13. Correct? So A of green is 13. So what we will do is we will change this 13 to an appropriate location, right? So which is going to be, um, yeah. So 78 got changed from between these two, right? So we changed 78 and 13. So the location for 78 was being pointed by the yellow, right? So yellow defines the end of the boundary where you had the elements lesser than that particular than the pivot, right? So now you will increment yellow again, and it'll point to 63 here. Okay, so you have all come out of the all the elements here. Again, remember, see what is yellow pointing to? Yellow is 4. That is 0, 1, 2, 3, 4. So 63 is what this points to. So basically what we're saying is from the yellow index above it, including it, are the elements which are greater than this than pivot, which is 43 in our case. Lesser than that is all less than 43, right? So we therefore yellow minus 1 is what is the right location of 43. So that's exactly what we're doing in this particular swap operation. Okay, so with this we see that 43 has come to the right location, which is 0, 1, 2, 3, 4, its fourth element, right? Now once we have sorted 43 in its right position, what we want is we want to sort the left half, left of 43 and right of 43. So left of 43 would be whatever is from the left to yellow minus 1. So yellow minus 1 would be the location to 43. Again, we use the Python convention and we say that until that location you have to sort. That is, it'll end up trying to sort from 13, 22, 32 and 22. And the right half would basically be the this part of the elements, which is 63 to 78. Okay, so let's just see that. So again, it's a recursive call. So it'll just immediately go into this and you can see what we're asking is you have to sort from 0 to 3, right? Which is the first elements 13, 32 and 22. Okay. Is that clear? So then it's straightforward. You will now just consider only until the first three elements. So hence this green range, whatever you have, the range goes from left plus one to right. So because that's the sub list that you want to sort in this particular call. Okay. Any other doubts? Any thoughts in this? Any doubts in this? So 13 is a pivot here. This will be straightforward. It won't do much here. Then, so now yellow is 1. So, and left is 0. So 0 to 0, it's asking to sort, which is again, doesn't make sense. There's nothing left here, right? So it's basically saying left of 13, because now 13 is the smallest element. Left of 13, there's nothing else present. So just continue. There's no work to be done. Again, remember, this was sorting from the 13 to 22. So 13 has been done. The right of 13, that is these two elements are pending. That is what you will solve from this particular from this particular recursion call, right? That is your yellow is 1, right is 3. So 1 and 2, that is second and third elements, right? And that you will again, yeah, this will basically shift it here, right? So now these two have changed their places, and then you will end up saying, okay, nothing else left. And let's see if, correct. So here is where we can see that all the elements in the left of 43 are all sorted, including 43. So we just need to sort the right side of 43, which is from 4 to the remainder until the right. So hence you're going to call this quicksort with this yellow, that is 4, which is location of 63, until the end, that is 8. Okay, fine. So that's how it will sort. Um, any doubts, thoughts, questions? Oh, it doesn't. Oh, it's in place, right? Yeah. Okay. Um, by the way, here, if you have to do the descending list, how will you do it? Any thoughts?
Pivot is there, right? Pivot to the pivot left, put the higher numbers, and right lower numbers.
Correct. So how will you do that in the code? How will you achieve that? Change plus minus. What is plus minus? Which plus minus?
have no A green less than or equal to A left. Instead of that, we can put A greater than A left.
Right. So I think that's exactly what should happen. So let's just see if it works. So the idea here is in the ascending case, yellow was sort of telling you until where the elements are which are smaller than the given element, right? The pivot element, right? Now here by changing this, in a way, what we're doing is we're saying that you keep track of where the elements which are greater than them are, right? And make sure all of them are, in their respective positions, right? So yeah, it has worked like a charm, right? So basically, yeah, so any algorithm, if you want to make from ascending, descending, very likely you'll just have to change some greater than, less than, all of that. But that's the idea, right? So if let's just see it in action, let's say. Um, Yeah. So now 43, if it is, if we have to make it in a descending order, where should 43 come by the end of the, let's say until this call, where should it come? Right? It's the, so nine, so these all elements are greater than this. So this will become the first four. So 43 will become the fifth element. Ideally, it should come to the fifth element, and the numbers which are greater than 43, that is all these four, should come in the left of 43, and these remaining numbers, 32, 22, 13, should come on the right side, right? So that if you check here now, yeah, so it keeps on going here. So now we'll shift. Yeah. So now if you see here, 78 has come here. Okay. Um, then you will see 63 has come here. Um, 57 has moved, and then 91 moves in, right? So now again, remember, yellow is basically for in our case pointing towards where until where the greater elements are. So now I just need to swap 91 with 43. And if that happens, 43 will be at the location where it's supposed to be, right? And that's exactly what has happened here, right? So then you will just apply this logic for the left half, left of 43 elements, and right of 43 elements. Okay, fine. Okay. So this completes quicksort and merge sort. Um, you have things like tuples, dictionaries, and stuff like that. So, mm, yeah. So again, remember, dictionary is again like a, it's like a mapping from one, from one value to another, right? So in this case, for example, this dictionary has the key values as strings, integers, tuples, right? And in dictionary, the key has to be only certain types. That is, for example, tuples, ints, and all of these sort of numbers, these sort of objects. But the values can be any kind, right? They can again be a dictionary themselves, right? So, for example, here, if I do d of hello, right? This is going to print another dictionary itself to me, right? That's the idea. And if let's say you want to get this element, let's say 3 comma 4, then the key has to be that tuple in that order exactly. Okay, then you will get the corresponding value stored against that particular tuple. Okay, again, this will be very useful for you to do in your question, yeah, week 4 programming assignment, because you need to sort of try to understand what the elements are, how many of them, what are the unique ones, and so on and so forth. So you can use dictionaries to help you understand how to do that. Okay. um, uh, Again, so y- yeah, so that's the idea. um, any doubts in dictionaries, what they represent, and how to use them? and you can check whether a particular key is present in the dictionary or not by using by using the in operator. Right? Basically, let's say if I have to check whether place is there as a key in dictionary, you can just do place in D, right? So place in D will give you false because there is no key in dictionary D which has a place as the key. Uh, versus if I do hello, for example, you will get true, right? So in this way, you can check whether a particular element is present in the dictionary as a key, and you can store any kind of value in the corresponding value for a particular key. Okay, all right. Then let's come to functions. So again, so in function definitions, the way you define keys will not return orderly. Yes, that's correct. So keys are in dictionary. The keys may not be given in a particular order, right? So d dot keys gives you the list of all the keys, right? So here is KL to 1020 hello and like that. But it's not guaranteed to be in the way you put it here. Okay. So for that, then you have to either sort the keys. If you want them sorted, then you have to sort the keys separately by yourself. Okay. So these sort of things are useful when you want to maintain some mapping, right? Let's say some student and their marks and stuff like that, right? So those sort of things you can use because you want to maintain like a one-to-one mapping of some value that you have. Okay. Yeah, that is correct. So it will not always do that. It's not designed to do that. It can, but it may not always do that. So you don't depend upon the fact that because you're getting one, like say even 10 times also, you can't be sure that the 11th time you will get in that order. Yeah. Okay. Um, then coming to function definitions. So we have already used functions in our previous examples, but if you have to define a function, that's the syntax is something like this. We use a def keyword to tell the Python that I'm going to define a function here. Fn is the function name, and then we have the set of arguments which the function takes in, followed by a colon, and then you can define the function, what you want the function to do here. Okay. Um, Now, then there are special things in Python functions, which is basically like a default argument, which is, for example, let's say if the caller, I mean the piece of code which calls this function to execute did not provide any value for, let's say, the third parameter, let's say C in this case, then use the value as 2 in the subsequent code, right? That's the idea. That basically tells you your default parameters sort of a setting, right? Again, in Python definitions, you cannot have default parameters present before not non-default, right? So for example, this sort of a function definition is not allowed, right? So all the ones which have default parameters have to come towards the end, and all the ones which are sort of compulsory. So A and B are compulsory parameters where the caller has to provide some or the other value. So they have to come in the beginning, and then you can follow you can have the default parameters. Okay. So this is not allowed, but this is okay. Okay. Now let's say we are looking at a very simple function where we just provide some four numbers and it just prints the four numbers as it is, right? We'll go through one by one and see if you can guess, what will happen if when I call that function in that way, right? So let's say if I do function of so now this function takes two compulsory parameters, two default parameters. So if I do fn of 4, what do you think will be the output? We'll just comment everything out. Hmm. If I do fn of 4, what will be the output? What will happen? Anyone?
Maybe error will come because B is not provided
B is
value.
not provided, right? Exactly. So in this case, you will have an error which will say that it requires one, it's missing one positional argument, and that argument name is B, right? So you have to provide a B, the value for B also, right? And if I do function of 2 and 3, then what do you think will be printed? Because now I'm providing both compulsory parameters.
2, 3, 2, 10.
2, 3, and 2 and 10, right? Because I'm not providing any value for C in this case. So C and D both take their default value, which is 2 and 10. Now in the third case, um, I'm providing a value for C, but not for D, right? So that's going to print your 2, 3, 4, and 10. So it's going to be 2, 3, and C takes the value 4, and D is not provided. So it will take the value 10. Okay. And the last case is where I provide the value for both C and D, and then I would get 2, 3, 4, and 5, right? Which is the value which I provide in this particular order, right? Now let's say if I want to provide a value for D but not for C, right? How do I do that? That you can do it in this form, right? Because again, remember when I was using function of 2, 3, and 4, the third argument gets assigned to the third parameter here by default, right? So hence C will take the value 4 but not D. Let's say I want to give special value for D but not for C. That you can do it only by this particular way of calling. So where you provide 2 and 3 to A and B, and then D takes 20 and C takes its default parameter, which is 2. So in this case, you can see you'll get 2, 3, and 2 and 20, right? So A is 2, B is 3, C takes the default parameter, and D is what is passed in the argument in the calling function. Again, here this one other way of calling the function. If you want to, if for example you want to provide an order in the calling calling method, which is not the same as the order present in the function definition, then you can provide it in this form, right? So here B will take the value 45 and A will take 23, and because I have not provided anything else here, so then you will have C will take its default parameter and D will take its default parameter. So as you can see here, then A is 23, which is provided here, then 45, which is B, and then 2 and 10. Okay. And in this case also, by the way, you cannot provide something like this. Let's say 20, right? So if you provide any parameters by their uh, you know parameter name, then you have to continue that particular way of calling, right? So here I have to give C equal to or D equal to, depending on what you want to do, but this will not be allowed, right? Okay. And then lastly, if I give a function of B is equal to 45, this will again throw an error because it requires because A is a compulsory parameter, so it needs the value for A also. Okay. Is this clear? Any other combinations you want to try? Is it okay? Okay. Um, and then
But
in my
you have allowed earlier function 2 comma 3 comma D equal to 20. Here we did not say A equal to 2, B equal to 3 or something,
yes.
right?
So yeah, yeah. Yeah, this is allowed. So basically, you can provide any of the non-named parameters basically. So
Mm.
the Python will basically just keep on mapping each of them by their respective positions. And once you start naming the parameters, after that you have to only name the parameters. You cannot provide the positional argument. That's the idea, right?
Okay.
So because I have started naming from the first itself, so then I have to provide a named argument to this also. I cannot give it a positional argument. Is that
Okay.
okay?
Yeah. Fine.
Okay.
Thanks.
Yeah. Um, then let's say, so Python also allows you to pass functions as arguments itself. So let's say if I define a function f which takes in a and b and then takes, let's say, g as the third argument, where g is supposed to be a function, right? And then basically runs a and b as arguments to this g function. So then we'll see how it works for this particular scenario. So where I'm calling this f function with two parameters 10 and 20, and fn, that is the function that we defined earlier, that is this fn function that prints four values. So then what will happen is it will run this function fn with these two arguments, that is a and b, right? Which is provided here. So then as you can see, this is basically running 10 and 20, which is a and b in our case, which is exactly what this would do, and we're using the default parameters of c and d. Okay. Not many programming languages support this sort of a thing, but Python does it. So that comes in handy when you want to change the behavior of some function in a very generic way, right? That's the idea here. So any doubts or thoughts on this? Let me know. Okay, fine. Um, we'll now go to comprehensions. So again, so the idea in list comprehensions is that you can use things like map, filter, and so on as arguments to, I mean, as a method to simplify some of the work that you would want to do. So for example, let's say you have a list of Celsius temperatures, and you want to convert them to Fahrenheit, because you want to apply the same, the same value, the same function to a particular Celsius parameter. You can code it up in this format, right? And then that's basically saying I'm using a list argument, and this map argument takes two parameters. One is a function which gets applied to every element in the input list, right? So this is a list which has four elements. Then what a map will do is basically it will take 0 and then run this function on this 0. So here c will be 0. It will run that function on with c is equal to 0 and then get the value out. Again 20, again 37, 100, and so on. And that is then converted into a list format. Okay. So this is what a map does. Okay, so again, let's just see output here. So what lambda does? So lambda is basically an anonymous function sort of. See, if I were to write something like this, Celsius to Fahrenheit, right? And let's say it gives me C, and then I will say return 9 by 5 into C plus 32, right? Uh, this is okay, right? So basically what we're saying is this function has a name. The name of the function is cell to fah, right? Lambda allows you to define a function on the go, and it doesn't have a name as such. It's an anonymous function, right? That's what it means. So this basically becomes helpful when you have like a very short functions, like one line function sort of things, where the idea is that whatever you compute, that becomes a return value also, right? You don't have anything very complicated to be done here, right? Let's say if you have something like which is like a two-step sort of a thing. Let's say okay, so if I had to write the same, uh, you know thing in two steps. That is, let's say scale is 9 by 5 into C, and then return scale plus 32, right? So this sort of uh, uh, I mean, here it can be converted into a single line, but if it cannot be converted, then this sort of a function cannot be made into a lambda function, right? So lambda function basically means you take in one or more arguments of whatever you have, and then you compute some number, some value, not number, some value, and that value is also the output of the function, right? So it makes that function in that form. Okay. Um, uh, and by the way, so here now, this one way of doing it, you can also present it like this. You can just do this as here, instead of passing, making this function anonymous, you can pass cell to fa here. Okay, you will still get the same output. I mean, that's what the, the map function does, right? So what map is doing is basically taking every element in this Celsius list or array or iterable, right? And it calls this function with the specific values, and whatever the function returns, it takes it as the output. Okay, and remember, see, the way I'm writing it here, this is not, I'm not doing cell to fa of Celsius again. Just the function name. The name of the function is what you will pass here. Okay, is that clear?
That means without map, we cannot use the lambda function.
You can use. So I mean, this is not. It's not uh, uh, good to do this, but you can do something like this. So cell to fa v3 and then call it lambda, right? I mean, you're just defining it in some other way. That's it. And see, it's already throwing. I mean, it's already saying that you shouldn't ideally assign a lambda expression, right? So it's frowned upon, but it's allowed. That's how I would put it. Okay. Yeah. So map basically does this, which is basically saying that, when you have like a iterable or a sequence of things to be done, uh, uh, you can do and you want to do like one over one after the other, then you can just do it in this map sort of a fashion. Okay. Um. Uh. Let's say. Yeah. Let's say if you want to get the square of the Fahrenheit.
Map is a function, right?
Yes, map is a function again. Map is a function. It's an inbuilt Python function which takes in two arguments. One is a function and one is some iterable. So same like how we had here. So where this function was taking some arguments and a function by itself. In the same way, map is also a function. Yeah. Yeah.
Yeah.
Yeah. Um, so uh, how do I do that? So, so, so let's say you want to do square of the Fahrenheit. Okay, for whatever reason. So one way, obviously, you can just do this. Okay. Other way is basically using multiple maps. See, map takes one sequence and maps it to another sequence, hence the word map, right? Um, Another way of doing it is basically something like this. You can say map again, right? Here, what I want to do is I have so what is the operation I want to do? I want to square that. I will define that here. So I will say x square. And what is the sequence upon which I want to do this operation? So that is this sequence, right? So that becomes the second argument completely. So second argument is a map by itself, right? Okay. This is what I mean. This is another way of doing the same thing. So you can basically use map upon map. You can use a sequence of maps by itself. Not a problem, right? Um, and let's just to make sure it's the right answer. So we'll just
Temperature may not mean, you can again convert that to Fahrenheit or something. First one.
Sorry.
One you are converting centigrade to Fahrenheit. The
Correct.
other map you can convert Fahrenheit to centigrade.
That's correct. Right. We can do that. Yeah, that's exactly correct. Right. Yeah. So as you can see here, both the things are matching. That's exactly what map does, right? And yeah, so we can try doing that. So you can take Fahrenheit as an input here now, and then convert it back to Celsius and see if your program is right? Okay. So this is about map as a list. I mean, a way to com compress lists, right? Now, a filter, on the other hand, works exactly what its name is. So it filters a particular, let's say, sequence of elements that you have. And again, for me, it's I find it easier to view it like this for once, so I'm clear exactly what is the output, where is the argument going, etc. So here, um, so we have a list of emails here, and then we're saying you iterate through the emails. You only give me those emails which satisfy some condition, right? So what filter does is it will apply each of the this lambda function upon each of these elements in this email, and it will check whether the output of this lambda function is true or false, right? If it is true, it will take that element into the list, the output list. Otherwise, it won't take it in that particular list. Okay, so that is what this filter function does. Okay, so we'll see here what's the output. So as you can see, based upon our condition, whatever our condition was, that is, it should have some at the rate symbol, it should have a dot symbol. Uh, based on this condition, we see that the right emails have been selected and not this random thing like a Bob ad, right? Okay, so filter basically requires filter takes in a function which gives you whether it is true or false. And see, map was changing the element because Celsius was getting each element in Celsius was getting uh, mapped to some other value. Filter doesn't do that. Okay, so filter is retaining whatever was present in the initial list. So alice at gmail.com, that's exactly what you also receive in the output, right? Bob at the rate was not present in this because it failed the condition. Okay, and again, same rules apply. You can obviously use another, like a named function, and then plug it in here. So you can, if you want, do something like this and say um, validity of the email, and then say uh, and then write all of this condition here and say return, right? And instead of this, you can just write validity, right? Again, remember, just give the function name, don't call the function here. That filter will do by itself. Okay, and then it will give you the valid emails from this list. Okay, fine. So this is how your filter works. Now you can combine again. So as I said, like previously, we can have you can do map of map. You can do filter of filter again, right? Uh, and you can also do maps of filters, filters of maps, and like basically any combination is fine. Okay, so let's say if you have the emails again. So what we want here is we want only among the valid emails which we have, I want the domain name, right? So in that way, then what this filter will do is it will basically help you filter out things like Bob at the rate, and then only among the valid emails will this particular map function be applied, which is basically saying you just split the string with based on this at the rate symbol that will give you first half and second half, left of at and right of at, right? And then you can say, okay, give me the second part of it. There is the right side in this case, right? So that will give you gmail.com and all of the other things. Okay, so you can do filters of maps, maps of filters, etc. Based upon how your need is. Okay, is that okay? But yes, I would suggest you use this in a bit. I mean, if you're using it, try to make it more readable, because see, already it's becoming too long to read, right? So then what you can do is you can write something like this. You can write valid uh, emails, right, as this filter of this one. Okay, this is easier to read. Just two things. Then you can write valid emails as a argument here. Okay, for the map. So then map will do that magic by itself. Okay. This is what your um, list comprehensions will help you do. Okay. Any other any questions, any doubts here? No? Okay. Um, so I think we have covered week 4, all the items. For your programming assignment, again, as I said, the histogram function and even this one, try to, I mean, think of using dictionaries, etc., to be able to map things from one place to the other. Okay, that should basically help you, do your programs here. Um, for the for the quiz, yeah, for the quiz, it's going to be straightforward. I don't think too much of a problem here. Um, week 5, shall we move to week 5 lectures? So in week 5, so first thing what the lectures deal with is something called as the exception handling, right? So in this case, so basically, let's say when you have any expected errors that you might get, for example, right, and you want to be able to handle those errors at runtime. Basically, let's say you were expecting some value to be in integer format, but you got string or you got float and so on and so forth. So if you want to be able to handle those particular scenarios gracefully, exception handling is one way of doing it, right? Um, so one thing that so the way the way Python does it is basically using this idea of try except blocks, right? So where you say that you try doing this particular set of things, and then if you have any exception, which could be any sort of given special names here, for example, zero division error or name error and so on. If you get some error like this, then do something gracefully and exit, right? Uh, and if you don't have any issues in doing this particular part of the blocks, you can just end up going into this else statement, right? So we'll see how this particular thing works, right? Um, yeah. So so first of all, if you have a variable which has not been declared, I mean, which doesn't have a value, but you want to use it for some purpose, that is basically going to raise a name error, right? That's again by default in Python. So we can see here, I'm trying to use something like uh, let me just do this. Y is equal to x plus 3, right? So x is not defined before till now. So then this condition, I mean, this statement will have a problem. So that is what we are trying to catch. If it is not defined, you have to do something, gracefully. So we'll see that here. So this throws a name error, right? And this name error, we are saying you catch it in this particular block, right? So you say if you get a name error or you get a key error, you run this particular part of the code. Okay, so we are saying here that there was some sort of a name or a key error, right? And again, so it depends upon what you want to do when the error happens, right? Here we're just printing, but you could have something like, for example, let's say print provide the right name or something like that, right? And so on and so forth. So that depends upon your use case and what you want to do with it, right? So let's say, so if I were to, let's say, you know, so basically what happened here was that it tried to execute the first statement. It got a problem there itself. So it came to this particular block of except block. Now let's say if this was removed, I just so this is my first statement that is in the try block. So as you can see, we're trying to divide by zero, which is not defined in mathematics. So then you try to do that, you will get in the block which is called zero division error, right? So we say we try to divide by zero, which is not allowed, right? And then you can try to see different things. For example, let's say if I have a dictionary which
So here, is it
download.
a keyword after except what you have written is a keyword?
So it's not a keyword, it's a built-in exception of Python. So except so the word except, the word try, the word def, these are
Yeah.
keywords. These are basically built-in exceptions of Python.
Okay. In a way, it is a keyword. That means.
In a way, it's a keyword, you can think. Yeah, that's correct.
Yes.
Okay. Then
Okay. Thank you.
huh. So if if you have a dictionary which has, for example, let's say L against 2, and if you try to use a key value which is P of K, right? So K doesn't exist in this particular dictionary key set. So then it would come as a key error. So then it's supposed to go in this particular block, which is name or key error. And that's exactly what's happening here, right? So then let's say if you try to do something like this, which is, let's say you have L is only one element, 0, and you want the third element, L of 2, right? Which is not exist. Now, that's not zero division error. That's not even name error, not even key error. So for that, we'll just get a this particular block, which says some other error, right? Okay. And then let's say if you were to have no problem while doing this try block, then it will go to the else condition, which will basically say all hunky-dory. Okay. Is that does this help you understand what this multiple try except blocks will do? Any questions? Let me know.
So it is like some try catch or something like that, or is just try accept?
Correct. So I think in Java it's try catch. In Python it's try except.
Okay.
Yeah. Okay. Um, so let's say if you want to be able to get this, uh, so there was some other error, right? But what is the other error? If you want to get that, so for that, what we'll do is we'll use this something called as a exception. So this exception is basically the if so basically all of these errors are special cases of this exception scenario, right? So you want to know what this exception was. So then you can use this to augment your understanding. So let's say if you were to do that, you will get that the exception was basically list index out of range, right? That's the exact error that was there. Okay, is that clear? So that will basically help you understand other what exact error was there. Okay, so now with this um, again, so there's also a concept of flow of control. So where, for example, let's say you're calling, let's say, function f. That function f calls a function g, and that calls a function h. And in h, there was some sort of an error that's happening, right? So depending upon where your try except block is, that will i- i- intercept this particular error. Now in this scenario, um, if I call, let's say, flow of control function here, there is nowhere this particular exception, that is division by zero, was caught. So I would get zero division error, which is, I know, division by zero we try to do. But let's say if I do somewhere here, right, try except zero division error, um, and let's say I do print um, on zero division, right? So then, because in the calling function, so basically it's the G function tried to do all of this operations, but while during the H execution, there was some zero division error that would basically get caught here, and then we would have this print output being popped out, right, which is found zero division. Okay. Now let's say if you caught it in a higher scenario, some other higher place, uh, instead of that, let's say except zero division error, uh, found zero division in f function. Okay, so now the thing is, because the exception was already caught, is already being caught and processed here at the G function level itself, it is not going to go, and try to again give the same error in F, right? In G. Yeah. So let's say if I do that, I would get here itself found zero division in G. Okay. Um, Now, so this could, so but first, example, you can have something like this. You can have zero division error, and then you can also have some other catch. For example, let's say print some other error, right? And then let's say if you do something else, let's say something like this, right? So k is equal to some dictionary L2, and let's say k of k, right? Okay. So now while executing H, you will not get that zero division error first, because you will have an error here itself, which is basically your key error, right? So in this case, what will happen is, let's say I'll just put that here. We want to know what the error is, right? So then what will happen is, you found a different error, which is not handled by the G function also, because G function handles only the zero division error. But F function has another except block where I can catch this particular any global exception. So that will basically come here. So some other error, which is here it's saying K. There's a K is a key error, right? Okay. So this sort of again, control where you can handle different errors at different levels. All of that basically helps you handle whichever area you want to handle the error, um, uh, based on your need. Okay. Is this clear, the flow of control idea in exception handling? Okay. um and so one last item before we leave. So uh, so in this merge sort example, no, whenever we are calling, we have this very irritating way of, we have to put all of this zero and this length of unsorted always, right? Um, can you think of any way you can fill up the value before itself? Because we already learned this idea of default values, right? So can I define the function like this? Can I define, a minute. Yeah. Can I define it like something like left equal to zero, right equals to length of a, right? So will this be okay?
But here you have not defined what is A, right?
Correct. That's exactly the problem, right? So in this case, what ends up happening is in your default parameters when you're trying to give default values for your parameters, they need to be defined at the function definition level itself, right? Because a is a parameter itself, we don't know what the value of a will be while defining the function, and hence this length of a cannot be computed, right? So so then what would be one way of doing this then? Uh, how to make this a bit more easier to solve?
So
Any
can we make
thoughts? Can we make?
can we make A as a list in the header, that template itself? A within parentheses like that, A equal to parentheses list or something. A equal to or list, the definition of list. I
Huh.
mean that square brackets. A equal to square brackets empty.
Okay.
Suppose we put it that way, then the default for that also
Huh.
list.
That's the default. No, but the point is this, right? You can call a with anything. No, you
Yes,
can call the function a with anything. Huh. Then this length of it will be wrong, right?
yes,
Huh.
yeah, correct.
Huh. So yeah, so this sort of an idea has been mentioned in the week 5, this none sort of an idea, right? So where the idea is that, let's say when you don't have a clarity on what the value should be and value should be, etc., you can do something like this. You can say right equal to none, okay, and left also equal to none, and then check for that particular scenario here. You can say if left is none, right? Then I will say left. So, okay, left being 0 has no problem. So let's just give left equal to 0. In right, there was a problem, right? So then you can do if right is none, right? Then I will just put right as length of a. Okay. So now this allows you to not, I mean, not be forced to write this sort of a condition always, right? And it also makes sense, right? So why would you when I'm calling the function for the first time, why should I tell the function that okay, you have to sort from the beginning to the end? I mean, that's obviously to be understood, right? So then instead of writing in this form, you can write it as you can leave all of this unspecified, right? So then by default, when you call the merger for the first time for the whole list, is going to use left as 0, and the right will be set to the length of a, which is exactly what we want, and then it will continue with the whole function. Now, and then again, remember, because in the recursive call, we are giving the specific values. We are giving left and mid specifically for the left and right. So then there's no problem. It won't overwrite what is being provided in this, because the default values are not used in this scenario, right? Okay, is that clear?
So none is the reserved word.
Yes, yes. It's also a keyword. Yeah, that's correct.
So means what? Actually, none means we don't know. That is the meaning, right?
Yes, so it's sort of saying nothing or don't know. All of those ideas can be conceptualized using none.
Like null in that things something null
Huh,
or none.
correct. So null, NA, all of these. So
NaN.
it could represent not available. It could represent not a number. All of
Mm.
those. So hence,
Yes.
then what happened is things like your pandas and NumPy library. So then they started doing more fine tuning. You can say you have specific way of saying nans, ways of saying infinity, not a timestamp. So those sort of things. NAT in
Something
pandas,
like
right?
we do not know at this moment or whatever it is.
That's correct. Okay.
No.
Um, so fine. So we'll close the session here. Any doubts in whatever we discussed today, or in the video lectures, if you have anything on the remaining parts, your handling files, string functions, formatting printed output. You can ask now, or we will anyway cover it in the next session.
Uh, what you have used today interface is still that one only? Yes. Jupyter Notebook or this?
This PyCharm.
Huh? This
PyCharm. This is
PyCharm.
PyCharm. Yes.
Okay, PyCharm. Okay, great. It's looking all white background. It's good. And these programs, where are they available? Week for these programs?
So they are available in the same Excel sheet. So if you go to the problem solving recording session here, this Excel sheet has a link to a presentation folder link. Okay.
Uh, uh,
So I'm uploading all the codes and all the things that we write here as a zip file or as a PDF in this.
got it, got it. Okay.
Okay.
PyCharm. Okay, okay, got it.
Okay. If there are no more questions, we'll close the session for today. Um,
Thank you.
Second, what is this? Once the course is completed, may we have a review session for the syllabus about things? Yeah. So we will have one. So we can have one additional session at the end of the 8 sessions. So it's 8 week course. So we are will uh, be here for 8 sessions. We can have one additional session. So we can have like one extra one at the last, right? Before your exams and stuff. So we can
Also,
discuss in general what the any doubt you have in the whole course.
yeah,
Yeah, go ahead,
also
Ravi.
you are having assignment or quiz or some sort of things. So instead of that, also some practice problems or programs. Yeah, could you also share some practice sessions, practice programs? Means
See,
question.
I think this had come before also. So you can ask on the Q&A forum.
Okay.
I specifically don't have any practice problems as such to provide. If the TAs or if other people in the group have, then you can ask them. You can ask them there. Yeah.
Oh,
ठीक है. We'll meet next Tuesday, same timing, same link. Okay.
yeah. Great.